All right, welcome back, Hononegah Geometry. Today we're going to talk about similarity, but before we get to that, let's actually do some warm-up questions, and everything's on dilations today for our warm-up. So, if you remember from section 4.5 on dilations, we always put the new over the original. So when trying to find your scale factor, it's always new divided by original. So in this picture, the P prime is 2, and the original is 3. And since that number is below 1, we would consider that a reduction. So anything above 1 is an enlargement, and anything below 1 is a reduction. The next one, new is 6. Original is 3. Reducing that would be 2. And that would be an enlargement, again, above 1. New is 8. Original 24. Reducing that fraction is 1/3, making that a reduction because it's below 1. And the last one, new is 3. Old is 4, making this also a reduction. All right, so here we go. Today we're going to talk about similarity and transformations. I can perform similarity transformations, I can describe them, and then I can also prove that figures would have to be similar. Here we go. Two figures are similar figures when they have the same shape, but not necessarily the same size. So this is not congruent. Congruent means it's the same shape, same size, and shape. This is just the same shape. So a dilation would create similar figures because ultimately all the angles would be the same, but the lengths would all be different. Okay, so this length, let's say it's 6, and this length is 10, but we would have the same ratio throughout. Okay, so everything is going to get blown up or we'll have a reduction or an enlargement of the same ratio. Here we go. Dilations are a non-rigid motion because they preserve the shape but not necessarily the size. A similarity transformation is a dilation or a composition of rigid motions and a dilation. Two geometric figures are similar if and only if there's similarity transformation that maps one figure to the other. Unlike congruence transformations that preserve the length and angle measure, similarity transformation only preserve the angles, unless the dilation is a 1 or -1. All right, so here we go. Now, performing the similarity transformation, notice we have two different ones here. And so we're doing a translation +5 and +1, or +5 for x and +1, and then a dilation. So we have multiple images happening here. So you may want to write out each of the points and then go to the next point. And so here we go. -4, 1. If I went +5 on the x and +1 on the y, A would be the point 1, 2. And then I do the same operation with each point. So +5 on the x and +1 on the y. Next, I'm going to do a dilation. So I'm going to multiply everything by 2. So I get 2, 4 then would be A double prime. 6, 6 would be B double prime. And 6, 4 would be C double prime. Now, ultimately they want the original figure and the ending figure. So it depends on if you want to do the one in the middle there. That's kind of up to you if you want to do that. So -4, I'm just going to do the beginning and the end. So -4, +1. -2, +2, and -2, +1. So this is a pretty small right triangle here. This is A, this is B, and this is C. The ending figure now. The ending figure would be +2, +4. I was hoping on changing colors there. +6. +6, and +6, +4. And so now this triangle has been shifted +5, +1, and then doubled in size. So this is A double prime, C double prime, and B double prime. Now, you may want to use the rule. I think that's the easiest way to do rotation. So the rule for 90 degrees, and I'm going to write that off to the side here. The rule for 90 degrees is if I have a point AB, then it would become the point negative BA. So let's do this rotation to find C prime, D prime, using that rule. So if negative 2, 2, I switch the A and the B and make the B negative. So I'm going to switch the B value. And so for C, I'm going to take the Y and make it negative 2 and then keep the X the same. The next one, I'm going to switch the Y and keep the B the same. And so there's my original point. Now, to do a dilation, I'm going to multiply this one by a half. Okay, so I'm going to multiply the X by a half and the Y by a half. The X by a half and the Y by a half. And so that gives me my image. And I'm going to change colors here. So the original is at negative 2, 2. Negative 2, 2. And positive 2, 2. So here's my original CD. Now, negative 1, and negative 1, positive 1. C double prime, D double prime. Questions? Make sure you talk to your teacher there. Next one. I have a triangle, FGH. I want a reflection on the x-axis. Again, if you want to use the rules, you can. So I'm going to find F prime, G prime, H prime. Not going to lie here, I don't usually like using the rules on reflections. I usually just go over and graph and then reflect on the other side of the line that I'm looking at. But for our purposes right now, I'll go ahead and write out the rule. So the rule for reflection on the x-axis is you keep x the same and change y. So I'm going to keep x the same and change y. So negative 2, 4, negative 4, and 2 still 0. Then I'm going to do a dilation. So we got F double prime, G double prime, and H double prime of 1.5. So now I'm going to multiply each one of these by 1.5. And so I'm going to end up with 1.5, negative 3. So again, multiplying by 1.5. Next one, I'm going to get 6, negative 6, and 3, 0. So I'm going to do the first image and the last image. So the first image is 1, positive 2, 4, 4, and 2, 0. So here's my original triangle, F, G, H. And now I'm going to do the ending, or the image triangle. 1.5, negative 3. So that one's off by 1 there. 1.5, negative 3. 6, negative 6. And 3, 0. And so you'll notice. Oh, my original H was wrong. I don't know if any of you noticed that. Oh, apologize there. Let me see if I can fix this quick. So it should have been at 2, 0. Looking at the wrong, there's H. And so 3, 0 makes H double prime. Next question. Describe the transformation. This is a little bit more complicated. Instead of me actually asking you to do a transformation, I am asking you to describe a transformation. And so the first thing in this one is notice that the image, or the pre-image, which is PQRS, is larger than WXYZ. And so I know I'm going to have a dilation. And it's going from the point 3, 0, negative 3 to the point 0, negative 1. And so that's a dilation of a third. So the first one that I'm going to write down is a dilation with a k value of 1/3. So that's going to make it smaller. Next, I have a reflection on the y-axis. So you'll notice that it not only does a dilation of 1/3, which makes it smaller, it then flips over the y-axis. Describe the similarity transformation that maps this. So again, I noticed that the original image is DEFG, or excuse me, DEFG, and the new one, it's been rotated and it's smaller. And so I always try to pick one point. So I notice that it's half, like this one is the 0.01, and this is the 0.0 negative a half. And so that's a rotation, and it's also a dilation. So let's talk about the dilation first. And it actually probably could be then just one dilation. If you remember from your dilation, you actually could multiply, since it looks like it's a rotation of 180 degrees, I actually could do a dilation with a k value that's negative, and then it would be negative a half. So it's half as large, okay? And that actually would do both at the same time. So you actually could do this in two different ways. You can actually talk about a rotation of 180 degrees and a dilation of a half, or just a dilation of negative a half. SAT question now. You're given the equation that relates x and y. What value x does the value of y reach its minimum? They want to know the vertex. Now, in order to find the vertex, you do negative b over 2a, so that's 7. And when you plug 7 in, 7 squared minus 14 times 7 plus 22. And so pull out your calculator, and you type that in, and you end up getting negative 27. So it says, what value of x does it reach its minimum? The value of x would be 7. The actual minimum value would be negative 27. If you have any questions, make sure you talk to your teacher, and good luck.